First off, the neuromuscular junction between the motor neurons signals the muscle to contract by releasing a neurotransmitter and acetylcholine into the synaptic cleft. With the action potential traveling down the sarcolemma and T-tubules, calcium ions are then released from the sarcoplasmic reticulum. The calcium ions then bind on troponin, and it moves the tropomyosin out of the way.
Once the tropomyosin changes its shape, the myosin can bind to the exposed binding site on actin. ATP is broken down. ADP and P are released from myosin. After the myosin forms with the actin, the ADP and P detach and the actin slides across the myosin, kind of like a power stroke.
ATP binds to the myosin head, which allows the ATP to release from actin. ATP then hydrolyzes with ADP and P, cocking the myosin head. Finally, calcium is taken back up into the sarcoplasmic reticulum. If calcium ions are still present, the entire sequence is repeated.
In the case of rigor mortis, the muscles remain contracted due to the lack of oxygen, meaning that there is a small amount of ATP present, so the myosin and actin filaments cannot be released and the calcium ions cannot be pumped out of the cells.